right, we're going to finish off this section with two different proofs. So go ahead and pause and copy down all the givens, the diagram, and set up your statement and reasons. We're going to fill this in together. So the first one gives you the reason as the given. So hopefully by now you know that we're just going to take a look at what they give us. So P is parallel to Q. So what this proof is asking us to do is say, all right, if we're given these two lines are parallel, angles 1 and angle 2, how can we tell that these are equal or congruent? Now, if we look at angle 1 and angle 2, this is actually alternate exterior angles. So this is the proof to prove that exterior angles are going to be congruent. So let's go ahead and take a look at our statements that they gave us. It says, step number 2 says angle 1 is equal to angle 3. So let's take a look at angle 1 and 3. All right, so angle 1 and angle 3 are what type of angle pairs? Corresponding. So the reason is we're going to use the corresponding angle theorem to say that we know, and I'm just abbreviating corresponding angle theorem, angle 1 is equal to angle 3 because corresponding angles are congruent. That is the theorem that we learned last section. So let's go ahead and look at 3 and 2. So taking a look at 3 and 2, what type of angle pairs are 3 and 2? Okay, hopefully you know that that's the vertical angles, and that's just the vertical angles theorem. And once again, I'm just abbreviating because the vertical angles theorem says that if you have vertical angles, then they're congruent or equal. So angle 3 is equal to angle 2. Now, we cannot just say, all right, angle 1 is equal to angle 2 because of alternate exterior. That's what we're trying to prove. So now what we're going to take a look at is our steps. And hopefully maybe some of you guys might have picked this out, but from step 2 to step 3 to step 4 is one of our properties. And this property shows up a lot of the times in this section with the parallel lines. So if you take a look, angle 1 is equal to angle 3 is equal to angle 2, therefore angle 1 is equal to angle 2. Well, if you take a look, 3's overlap, and we can say 1 is equal to 2 by the transitive property. Okay? So always keep an eye out in this section for the transitive property because 9 times out of 10 it will be within the proof. So let's do one more proof, okay, from this section. So go ahead and pause and copy all this down, and we're going to fill in the reasons together. So let's go ahead. Every time they give you all the statements and you need to do the reasons, I tell you to find the given. So G is parallel to H. So let's go ahead and fill in this given. And then there's a second given, angle 1 is equal to angle 2. Well, that's actually step 3. We're going to go ahead and fill that in right now so that we don't get confused later on when we're going step by step. Now, this proof is slightly different. The last proof asked us to prove that the angles were equal, or the alternate interior or alternate exterior angles proof. This is proving parallel. So anytime the proof asks you to say, okay, these lines are parallel, we're going to be using that converse where we flip it, that section 3.3 we just did. So that will be one of our, or the final reasoning for number 5. We just have to go through all the other steps. So let's go ahead and take a look at what they give us. G is parallel to H, so I'm going to go ahead and put our parallel in. And then it says, all right, if G is parallel to H, we know that angle 1 is equal to angle 3. So taking a look at 1 and 3, those are, once again, corresponding angles. So we know by the corresponding angles theorem that 1 is going to equal 3. Now, we've already done step 3. It says, well, 1 is equal to 2 because that's part of the given. So let's take a look at number 4. It says 3 is equal to 2. Now, we don't know 3 is equal to 2 by alternate exterior. And the reason being is because they didn't tell us that P and R are parallel. So we can't say for number 4 that they are congruent. But what I was just talking about with the property, okay, let's take a look at this. These 3 is equal to 1, 1 is equal to 2, therefore 3 is equal to 2. Well, the 1's overlap and cross out, and let's combine 3 and 2. That will give us the transitive property. Okay? So now, let's take a look at this final step. It says, once we get from step 4, 3 is equal to 2, then we can say that P is parallel to R. So, remember, these are alternate exterior, but because we're doing parallel, we can't just say alternate exterior angles. we're going to do the converse, okay, of the alternate exterior angle theorem. So whatever angle pair is right before that, whatever's right, alternate interior, corresponding, whatever's before, it's always going to be the converse of that. All right, so I'll see you guys tomorrow in class. That's the end of this section.